4.6 is on inequalities, and we've done inequalities in a previous unit, but remember, inequalities do not use an equal sign. So they will use greater than, less than, greater than or equal to, or less than or equal to. And we are going to do them for both polynomials and rationals. So remember, rational functions can be written as fractions. They will have variables in the denominator. Polynomials will be something like, I don't know, x to the fourth plus 5x cubed plus dot, dot, dot. So our two objectives are to solve polynomial inequalities and solve rational inequalities. So let's look at our first example. Solve the inequality, then graph the solution set on a real number line. Well, if we're going to solve this, I want us to get everything on one side. So I'm going to subtract 15 over so that we have 0 on the other side. Kind of like what we do with equations sometimes, we'll set it equal to 0. Well, here I'm getting 0 on the other side. So now what I want us to think when we're doing this, to solve this off to the side, let's first pretend like it had been an equation, like it was equal to 0, and let's solve that. Let's figure out what makes this thing equal 0. Because I have something squared, something not squared, and a constant, I would try factoring first. So I want to multiply to negative 30, and I want to add to positive 1. Two numbers that multiply to negative 30 and add to positive 1. 6 and negative 5, so let's do the rewriting step. Now we're going to group. Take the GCF out. And now I can see they both have an x plus 3. And I want to set each factor equal to 0. So subtract 3. Here I would add 5 and then divide the 2. So I get negative 3 and I get 5 halves. Those are the two numbers that would make it equal to 0. Now, unfortunately, those aren't my answers. If the original problem would have used equals, yes, I would be done. I found the things that make it equal. But this problem was asking for what makes it greater than 0. So how do we do that? Well, there's just one extra step. So what I want you to picture is like a number line. And on this number line, we're going to put our zeros, the two items that made it equal 0, and we're going to put them in order from small to big. So I'm going to have my negative 3, and I'm going to have my 5 halves. So now what I want us to do is we're going to pick some numbers. So on this number line, I want you to pick something smaller than negative 3. I don't care what it is as long as it's left of negative 3. So you could pick negative 4, you could pick negative 50, you could pick negative 8.2. I don't care as long as it's left. So I'm going to pick negative 4. And we are going to substitute that back in. Now when you substitute it in, you can put it into this guy. I'm actually going to use the factored form because I think it's a little more user-friendly. I don't care where you substitute it in. So I'm going to take I'm picking negative 4, and if I put that into the factored form for the x's, negative 4 plus 3 is negative 1. 2 times negative 4 is negative 8 minus 5. So I get negative 1 times negative 13. So do you agree that I would get a positive number out? So what I'm going to do is I'm going to mark on my number line, if I pick anything left of -3 and I substitute it in, I'm going to get a positive answer out. Now I want you to pick something in between -3 and 5/2. I don't care what it is as long as it's in between. I'm going to pick 0. So if I plug 0 into my factored form, I'd get 3, and on the other one, I'd get -5. I'd get a negative number out. So I'm going to indicate that anything that I substitute in between will give me a negative answer out. And then I'd like you to pick something greater than 5/2. So I think because that's 2.5, I'm going to pick 3. So if I plug 3 in for the x's, I get 6, and the other guy would come out to 1. I get a positive number out. We are ready to answer this problem now. Where are my answers? Well, I want the regions that come out greater than 0. The regions that spit out answers greater than 0 are here and here. That's where I was getting positive answers out, answers bigger than 0. So to write this as your answer, we're just going to use interval notation. So I would say one place would be -infinity until -3, or, and now I'm going to write the other region, 5/2 to infinity. Why did I use parentheses and not brackets? Well, if I look at the problem, see how it was just greater than? It did not have the equal to bar, meaning I don't want to include the numbers. So this is my answer. Anything in these intervals will cause me to get answers out bigger than 0. That's what that means. If it wanted me to make my graph on a number line, it's been a while since we've done this, but hopefully it will come back to you. This is where I would just do parenthesis, shade, parenthesis, shade. That would be my visual graph. Okay, let's try another one. So if I would like to solve this inequality, let's get everything on one side first. I'm going to move these guys over. I like to keep the leading term positive if I can. So I'll have x cubed plus x squared minus 4x minus 4. I subtracted them over. So off to the side, let's think about this as an equation, like I'm actually going to set it equal to 0 and solve it. Because there's 4 terms, let's group it. So from the first group, x squared. From the back group, -4. So I get x squared minus 4 and x plus 1. Set each piece equal to 0. So I get -1. This guy I would add 4 over and then square root it. Make sure when you square root both sides, we get a plus minus 2. So there's 3 numbers here that I have to deal with. -1, 2, and -2. So those would have been my answers if the original problem would have been an equation, but it's not. So let's put our numbers in order from small to big, small to big, and now we're going to have to check things. So I need a number left of -2. I don't care what it is, it just needs to be left of -2. Let's do -3. So I'm going to put it into the factored form. So -3 squared minus 4 and -3 plus 1. So negative 3 squared is 9. Minus 4, I'd get 5. Negative 3 plus 1 is negative 2. So I get a negative number out. Okay, now I want to pick something in between negative 2 and negative 1. I would probably do negative 1.5. Okay, I'll tell you, if you simplify this guy squared minus 4 would give me, let me see here. You should get a negative number. And this other guy would also be a negative number, and when I multiply them together, I will get a positive number. Again, I don't really care what number comes out. I'm more concerned with, does it come out positive or negative? Then you'd want to check something between negative 1 and 2. I would do 0. So if you plug 0 in, we'd get a negative 4 times 1. I'd get a negative number out. And then you'd want to pick something bigger than 2. I'd pick 3. And I'll tell you, if you plug 3 in, you get a positive number out. So now let's answer the question. Where are my answers? Well, I want to be less than or equal to 0. So less than 0 would mean the negative regions. So let's write that in interval notation. So that first interval would be negative infinity to negative 2, or negative 1 to 2. Now, why did I use brackets? Well, on the inequality, I had the equal to bar, meaning I want to include the numbers that make it equal to 0. If I were to graph this on a number line, you'd basically have a bracket, shade, bracket, bracket, shade. The next guy is kind of an oddball one. It's already ready to solve, so I'm going to think of it being equal to 0. Let's see if it will factor. I want to multiply to 9 and add to 6. It does. 3 and 3. If I set them each equal to 0, I get negative 3 twice. We would say it has a multiplicity of 2 because I get it twice. So when I go to make my number line, I really only have to put negative 3 on there once. And now I want to check numbers on either side. So if I pick something to the left, if I pick negative 4, I'd get a negative times a negative. So it would come out positive. And then if I pick something right, I'll pick 0. A positive times a positive. That's interesting. Now let's answer the question. What am I looking for my answers? I want the numbers that come out less than 0. So the negative regions. Well, there are no negative regions. So how would I say this? Well, turns out this is no solution. There are no negative regions, or you could use this symbol. I didn't get anything to come out less than 0. Next one. It's ready to go. So if I picture, like, I'm going to find what makes it equal to 0, multiply to 1 and add to 2. So 1 and 1. I get negative 1 with a multiplicity of 2. I'd get it twice. So if I made my number line, I'd want to pick something left of -1, so I would do maybe -2. If I plug that in to my factored form, I'd get a negative times a negative, so I'd get a positive. And then if you pick something right of -1, I'd pick 0. I'd get a positive times a positive, so positive. And now let's answer the question. I want the answers that are less than or equal to 0. And you might say, well, there's no negative region, so it's no solution again. And I would say no, because on this one, it also has the equal to bar, meaning I can include the numbers that come out equal to 0. So this is a weird one because the only answer would be -1. That is the thing that makes it equal to 0. I don't have any regions that make it come out less than 0. So I have a single number for this answer. Okay, let's look at this guy. Let's solve it. So multiply to 4, add to -4. Solve each. So I get x equals 2 with a multiplicity of 2. So now, let's make our number line. I only have 2 to put on there. I'm going to check something to the left, so I'll do 0. So I'd get a negative times a negative, I'd get a positive. And now let's pick something to the right, I'll do 3. That'd be +1, +1, multiply them, I get a positive. So where are my answers? I want the answers that come out greater than 0. So the positive regions. Now, sometimes people ask me, oh, great, can I just say -infinity to infinity? It's the entire thing. And I will say no, because I have to throw out 2. Why do I have to throw out 2? Well, 2 is the number that will make it equal to 0. And I did not have the equal to bar on the inequality, so I can't include 2. I have to throw it out. If the equal to bar would have been there, then yes, you could have just said -infinity to infinity. We'd include everything. If you were to graph this one, here's what would end up happening. Parenthesis, shaded. It's like you would see back-to-back parentheses. The final few examples that I would like to do are the rational inequalities, and they work the same way except one catch. These are the guys that are going to have variables in the denominator. So when creating a number line for rational inequalities, you must also include the zeros and the undefined values. What do I mean by that? Well, let's do an example and I'll show you what I mean. So solve the inequality, then graph. So we're going to do the exact same thing we were just doing. So this first guy here, let's first figure out the undefined values. What would cause me issues? So if I said, what would make the bottom 0? What number would I have to throw out? Well, if you're not sure, let's set the denominator equal to 0, just like we've done many times before. And it's already solved. So I do not want x to be 0. We're going to come back to that in a moment. Now, let's take our guy here and set it equal to 0, like we're going to solve the whole thing. So how would I solve this? Well, we could times by x to get rid of this division. Anything times 0 is 0. Now I'm going to add 1 over and then square root. Make sure you get plus minus 1. Okay, so now comes the part, just like the other ones, where we're going to make our little number line. And on my number line, I'm going to have my -1, 0, and 1. The only difference with rational inequalities, you have to also include the undefined values on your number line. Why? Well, the undefined values are going to make vertical asymptotes. And like we saw on the previous section with graphing, the graph could change what it does on either side of the vertical asymptote. Okay, so now we are going to plug in numbers. So let's pick something left of -1. I'll do -2. So if I substitute it in, -2 squared would be 4 minus 1. I'd get 3 over negative. I get a negative number out. Now let's pick something in between -1 and 0. I'd pick like -0.5. So the bottom I know is negative. Oh, why did I do a -2? Not -2. -0.5. So I know the bottom is negative. And the top, if you simplified that in the calculator, it also comes out negative. I don't know what the number is off the top of my head. I don't really care what the number is. If we have a negative over a negative, it's going to be a positive number. If you continue picking numbers, so pick something in between 0 and 1, and if you plug it in, I'm going to tell you you get a negative out. And if you pick something bigger than 1 and plug it in, you're going to get a positive number out. So now let's answer this. What are the answers that I want? I want the answers that come out less than 0. I want the negative regions, less than 0. And will I use parentheses or brackets when I write this? Should be parentheses because I don't have the equal to bar. So I would say -infinity to -1 or 0 to 1. That would be my solution regions. If I graph this on a number line, I would see parenthesis shaded, parenthesis shaded. Okay, let's look at the next guy here. Let's first figure out what would make the bottom 0. So I want to figure out my undefined values. If I set the bottom equal to 0 and solve, I get 5. So 5 would make the denominator 0. So we'll come back to that. Now I want you to picture we're going to solve this. So picture we're going to set it equal instead of the inequality symbol. So now how do I solve this? Well, let's solve it the exact same way we were doing all the others. So I'm going to multiply by the x minus 5 to cancel out the division. Now make sure on the right side, since it's not 0, we have to distribute this 3. And I get 3x minus 15. Now I think I'm going to subtract my 2x. And then I'm going to add my 15. So I get 8. Number line. Two things on my number line, my undefined value of 5 and my 0 of 8. All right, so now we are going to substitute numbers in. And what I recommend doing before substituting numbers in, just to make sure we read this correctly, our inequality up here, I'm actually going to subtract the 3 over, because I want you to think of it like this. I want us to see that 0 on one side. So I just subtracted the 3 over. So you could probably just do this in your calculator. If I pick something less than 5, I'll pick a 4. 2 times 4 minus 7 over 4 minus 5, and then minus 3. If you do all that simplifying, you should get a negative number out. If you pick a number between 5 and 8, you should get it positive. And if you pick a number bigger than 8, you'll get a negative. So now I want to answer the question. Do I want the negatives or do I want the positives? Well, if you look up where I got 0 on one side, I want to be less than or equal to 0. So I want the negatives. And will I use parentheses or brackets? We should say brackets because we have the equal to bar. Now, unfortunately, if you had this as your answer, you would be wrong. There's one thing wrong with this, and I'll tell you the thing that's wrong. It's not actually a bracket with the 5. It's a parenthesis, and you might be saying, why? We have the equal to bar with the inequality. Why isn't it a bracket? 5 was an undefined value. It's what made the denominator 0, and I never want to include those. If I made the graph, that's what our graph would look like. Grand finale. All right, let's first find the undefined values. So I have two denominators that I'm going to work with. So I get 6 and negative 2. So I'll have to keep my eyes out for those two things. Okay, now I want us to solve this. So let's pretend that there's equals. So now how do we solve this? Well, I'm going to times the x plus 2 over. And at the same time, I'm going to times the x minus 6 over. So it's like I'm cross multiplying. So the 5 will distribute. And on the other side, the 3 will distribute. So the x plus 2 went to the 5, and the x minus 6 went to the 3. Now I'm going to subtract 3x. I'm going to subtract 10. And then divide by 2. Number line, make sure we put them in order from small to big. So I have my negative 14, I have my negative 2, and I have my 6. All right. Before we start testing values, I'm going to take my inequality and I'm just going to subtract that entire fraction over so that I have 0 on one side. So I just brought the 3 over x plus 2. I subtracted the whole thing over. So let's pick a number left of negative 14. So you could do negative 15. I'll tell you, if you substitute that into this guy on the left, you should get a negative number out. And then if you continue checking, these are the signs you should get. You're just substituting numbers in. And now let's answer the question. I had greater than 0, so I want the positive regions. And will I use parentheses or brackets? I should use parentheses because I don't have the equal to bar. There would be my solution intervals. And if I graphed it, I have parenthesis, parenthesis, parentheses shaded.